I think with this, we'll start our today's webinar. So this would be the topics which I'll be covering: the transport rail, lifelines, railroad technology, metallurgy and its role. And once again, I would like to mention that I will be keeping it a bit basic so that each and everybody can understand it. So it will not be a problem. So to start with, as you all know that transport lifelines of nation are the transportation and the communication are the main lifelines of a national economy. And in this, roadways, airways, waterways, and railways play a major role, especially in India. Railways play a very, very major role, and it is also contributing to the almost a very good percentage in the GDP. So almost in one of the report, it was mentioned almost 2% of GDP it is contributing, and a lot of scope is there in the development of these railways nowadays. So about the railways, as you know, it is a major way of transportation in India, and it is the major playmaster in the Indian economy, as I mentioned. And this is the world's one of the largest railway systems in the world under one single management. And the railway market is almost third largest right now, and we are moving towards the third largest rail network in the world, accounting for 10% of the global market. And we are going to think about our ambitious project, Indian Railways' ambitious project of launching the high-speed trains and also the dedicated freight corridors for increased capacity of tonnage goods travel across the country, right? And also the action plan of the IR to make India a $5 trillion USD economy by 2025. So few facts, as you all know, once again, I would like to remind you that the Indian Railway has almost a route length of 1,21,407. The first largest is the USA, then we have the China, then Russia, and then we have India. And the passenger trains and freight trains have and good number of freight trains, because we have almost 2 crore people traveling every day, 3 million tons of freight moving across the country every day. So Indian Railway is almost targeting an increase of 3.3 billion tons by 2030. Right now, it is almost 1.1 billion ton. And major thing is, as I told you, the ambitious project, that is a bullet train. The major region is Mumbai to Ahmedabad. And as you know, already we have a semi-high-speed train, that is the Gatiman Express, which moves from, I guess, from Delhi to Agra, which has a speed of almost 160 km per hour. And the upcoming bullet trains will be going for 200, and then the next phase will go for the 250, then we go for the 300. So as I told you, we have almost 165 years of experience, and why we are so much concentrating on railways, and now why railways has come up with so much growth plan. The main part is we are going towards urban development. And you know, last 2 decades, we are able to see a significant increase in the metro lines. And metros means we are talking about the urbanization. So cities are increasing. So the connection between the poor, the rural areas, and also the cities is quite increasing nowadays. And each and every state has its own plan of metros. So for the metros, as you know, we have few constraints, we have few limitations, like we are trying to do it on a tunnel, or we are planning for a overbridge or any other way. So we don't have rails right now which can suit to the plan for the metros. So that is one point. And for high speed, which we require less than 700 meter and so those things I will talk in the later slides. You will have a clear understanding. So establish a separate high-speed corridors by 2023. That is our target, how fast we are going and how fast we can achieve it. Another point we have to understand here is uh, we are able to move towards these high-speed trains only when we have sufficient rails to be manufactured with good properties. So, as you know, the Make in India initiative of Government of India really helped whole Indian economy to move forward, and it has given a chance to the private firms to develop rails in a better way and better properties than importing them from the other countries. So first we'll see about the railroads. So as you know, the steels were the rails when in 1857 at Derby Station, they have installed the steel rails. Earlier, they used to use wooden rails and cast iron rails, but due to their poor properties of the materials, we are not able to use that materials. So we came up with the Bessemer steel earlier, and the other part I'll repeat this slide at the later stage because this is a very too early to understand the grades and all. So as you know, I think you already know these railroad construction, but still. So this is a which has different steps like ballast, sub-ballast for drainage of the water and all. And then we have a cross-stay or sleeper, which will rail, and then the fasteners and chair to hold tight of this rail. And then we have the rails, right? So we have the fish plate earlier, which is a joining of two different rails. Nowadays we are going for a welded rail. So we have number of welds at this particular point. So there is less fish plates required. Though this fish plate generally holds the rail tight. That is one main thing. So ballasted track and non-ballasted track. So where do we use this? Yes, ballasted track is used for the low-speed trains and all. And non-ballasted tracks are the latest developments where we can use this for the high-speed trains. So ballasted tracks have some issues like it can produce noise, and we can have one important point is we can also have a plan to modify it at the later end. But if you're going for a high-speed train, if you construct a concrete based non-ballasted track, then it is done. We cannot modify it a bit also. So that is one small issue. Overall, cost-wise, ballasted track are a bit cheaper. Non-ballasted track are costly, but the maintenance cost is quite low. That is one important thing. And the service life is almost around 50 to 60 years. And I could, in some literature, I could see the ballasted track is having almost 20 to 30 years. So almost it is double. So that is one important point. So when we are planning for the high-speed trains, we go for the non-ballastic tracks. As the rail gauges is one other important point. It talks about the minimum distance between the two rails. Okay, vertical distance between two rails. So there are various gauges, as you know. This all depends on the speed of rail and the track stability. If you are going for any Dehradun trip or the Ooty trip, you could see a meter gauge. Or if you go to a normal travel to different cities, you see a broad gauge. So anything which is bigger than the narrow standard gauge is our broad gauge. So these gauges have gives an idea that how stable the train can move on that particular rail track. So standard gauge is almost 1435 mm, that is for 4 feet 8.5 inch, and broad gauge in India it is 5 feet 6 inch, and I think in Japan and other places I could see broad gauges of 7.5 feet, right? So main here, the broad gauge gives track stability and useful for the high-speed trains also. So coming up with the rail types, yes, we have various rail types earlier, but right now we are having almost 90% across the world. We have the flat-footed rail. It is also called as Vignol's rail. So Vignol's is a scientist, engineer who prepared this type of section, that is a flat-footed section. So we have a double-headed rail earlier. So double-headed rail is nothing but these rails were developed only to were developed by, I think it is the wrought iron